Well, today is December 19th, which is 6 days before Christmas, but it is the day that 3I Atlas, the third interstellar object to enter our galaxy, is closest to Earth. And who knows what the heck that's going to mean, and who knows what the heck it is. But we'll find out today when I talk to Avi Loeb, Harvard astrophysicist, who returns to our show for the fourth time. And you, my dear listeners, have an extra special present right now. You can listen to the podcast here, or you can go to the Signal Network on YouTube, and you will find the video version of this podcast where you can see me and Avi on camera and in all our humanity. So pick your pleasure, but going forward, several of my podcasts going forward will now be available as video as well. So you can either listen to them if you prefer audio or watch the video. So enjoy the show.
In a world where nothing is known, nothing is certain, reality is not real. Wake up! Be afraid of nothing. I'm Bob Heskey.
Robert.
The host with the ghost.
This is my podcast, based on my paranormal documentary, Afraid of Nothing. Each episode, we talk to people who see life and the afterlife through a different lens. Join me.
Who is this large man? And what's he doing in our bedroom?
As we lift the veil and open our minds to see beyond our eyes lie. This is Afraid of Nothing.
All right, I am here with Dr. Avi Loeb. This is his fourth time to the show. Thank you so much for being with us again, Avi.
My great pleasure. Thanks for having me.
And I know we had a little bit of a technical difficulties getting set up, so thanks for your patience. Would you do me a favor, and for anyone who's been living under a rock or the third rock from the sun, would you briefly introduce yourself to our audience? And because you've been everywhere lately in the news and media and podcasts.
I'm a professor of science at Harvard University. I was born on a farm and was always curious about nature. And now I have the privilege of pursuing a better understanding of the physical reality that we live in as a scientist. And I chaired the astronomy department at Harvard for 9 years. I served as director of 2 centers at Harvard. I chaired the board on physics and astronomy of the National Academies, a member of the President's Council on Science and Technology Advisors at the White House, and various other leadership roles.
The thing we've been hearing about a lot is 3I Atlas, and that's the third interstellar object to kind of enter our galaxy in the past 6 years or so. The first one, you were very much one of the first observers on and to call to the attention. But now this third one is much bigger and making a much bigger impact, and everybody's paying more attention. What is 3I Atlas, and why are people so focused on it right now?
Well, it's the third object that astronomers discovered through telescopes that came from outside the solar system. The first one was discovered in 2017. So only for 8 years we found such objects. And this one was discovered on July 1st, 2025, with a telescope called Atlas in Chile, 0.5 meter in diameter. And it was very bright. And in fact, it's much more massive by 1 million. Than the mass of the first interstellar object, and that's surprising that we received such a big package. We don't know exactly its size, but these are the current estimates. And moreover, its trajectory is aligned with the plane of the planets around the sun, and that is a very unusual property. Within 5 degrees, the chance for that happening at random is 1 in 500. And this object is also quite unusual in having an extension of the glow around it in the direction of the sun. It's called an anti-tail because usually for comets we see a tail extending away from the sun because dust and gas are being pushed back away from the sun by the solar radiation and the solar wind. And in this case, it seems like there is an extension towards the sun. And we saw that on July 21st when the first image from the Hubble Space Telescope was taken. And now we see it again. The Hubble telescope just at the end of November took an image of 3i Atlas when after it passed closest to the sun. And that happened on October 29th. So a month later, the Hubble telescope again sees a teardrop shape for the glowing halo around this object, and it's pointing towards the sun. Now it's reversed in orientation relative to the motion of the object. And after it passed closest to the sun, we also noticed that there are many jets coming from it, some away from the sun, some towards the sun, and it's not clear what the nature of these jets is. And it passed closest to Mars on October 3rd, and then it will pass close to Jupiter on March 16th, 2026. And in addition, there are some anomalies related to the composition of the gas around it. For example, there is a lot of nickel with very little iron, and usually nickel and iron come together in comets, and except in the context of nickel alloy that are produced artificially. And so the fundamental question about this object is whether the trajectory was designed by some intelligence, whether the object itself is technological or not. And, most likely it is natural, but then there are some anomalies that have a very small probability of happening. We've never seen them before. And then the question is, perhaps, it might be a black swan event where we give a small probability for it being technological, but the implications of it being technological would be huge for society. And therefore, in my opinion, we must take it seriously and get as much data as possible about this object.
Do you feel people are taking it as seriously? I mean, it seems like NASA's been a little slow to the table about releasing information on that. What's your feeling about how the public and, the scientific community is reacting to this versus Oumuamua, where you wrote a book about?
Well, so Comet experts behave just like AI systems. They were trained on data sets that include the icy rocks in the solar system, and therefore anything in the sky for them would be icy rocks. What I'm trying to argue is that they should add to their vocabulary also the possibility that some of the objects that enter the solar system might be technological, because we launched a lot of equipment to space, and there are 100 billion stars like the sun in the Milky Way galaxy alone, and most of them formed billions of years before the sun, and it takes less than 1 billion years for even our own technologies in the form of Voyager from the 1970s, to cross the Milky Way galaxy disk. So there was plenty of time for such objects to reach us. And unfortunately, as soon as this object was discovered, it was announced as a comet without much thought given to the anomalies of it. And I'm disappointed by that, because we should be curious and collect as much data and examine it without any prejudice, without assuming that it must be the type of objects we've seen before. And in fact, it's not. It's very different than solar system comets. And that to me implies that we are missing something. We will learn something new, irrespective of whether it's natural or not. And one thing that the scientists are missing is that when you have a visitor to your backyard, you can't afford the luxury of saying, it's most likely something that I'm familiar with, like a street cat, because the implications could be very large if it happens to visit your front door or leave some devices that will stay in the solar system. And so we must consider each and every object coming into the solar system with a lot of attention. And in my view, it's a subject that did not receive enough attention. And we, of course, have a planetary defense office in NASA, but it's related to rocks that may impact the Earth. We know that the dinosaurs were killed 66 million years ago, so we might want to deflect rocks before they reach the Earth. However, a technological object can maneuver and might have an intent and might have technologies superior to what we are using. So it's a completely different threat. And my point is, we will, after the first encounter, we will have no choice but to consider it seriously. And then we might allocate large sums of money to space exploration. But I'm just trying to bring it to the attention of both scientists and policymakers before it's too late.
Who is being kind of receptive to you, and is anybody kind of not being very cooperative in terms of who you're talking to in the scientific community and NASA?
Actually, in Congress, there are a number of people that were very attentive, including Congresswoman Anna Paulina Luna, that notified NASA through 2 letters that she wrote, encouraging them to provide as much information as possible from all the space assets that NASA has. And now NASA woke up recently, and they had a press conference, although the images they released were quite fuzzy and not particularly informative. And the problem is that NASA is being controlled by bureaucrats. It would have been much nicer if scientists would have more of a say as to how NASA responds to situations like that. But there are also members of the academic community, astronomers, that are self-declared comet experts, and they say they know the nature of the object without even getting much data about it. The point is that we only had 3 interstellar objects discovered by astronomers, so you cannot be an expert on a study of 3 objects, and that makes no sense of them to claim that they know what these objects are. Especially Oumuamua, the claim now is that it was a dark comet, meaning a comet where we couldn't see the cometary tail or any evidence for it being a comet, and that's an oxymoron. And it's unprofessional of those people to claim that they are experts that should tell us what the nature of the objects is. And I'm much more in favor of science of the people. And in fact, a lot of amateur astronomers collected very valuable images over the past month that give us much more information with telescopes that cost thousands of dollars compared to NASA that operates instruments that cost billions of dollars.
What is your thought? Yeah, dark comet. I've heard it referenced. You think that's kind of an oxymoron, which it is, right?
Right. So they invented this phrase because Oumuamua, the first interstellar object, was exhibiting non-gravitational acceleration. There was some force pushing it away from the sun, and in the case of comets, that's a result of evaporation, and you need about 10% of the mass of the object to have been evaporated to provide it with the additional acceleration that was measured. But we haven't seen any gas or dust around Oumuamua, and in fact, the Spitzer Space Telescope looked very deeply. So even quantities that are much smaller than 10% of the mass of the object should have been detectable. But they say it's a dark comet, meaning a comet which does evaporate, but somehow the gas coming off it is invisible to us, which we've never seen before. And of course, you can imagine a spacecraft or any technological object. For example, an object that is thin would be pushed by reflecting sunlight and has nothing to do with evaporation. And 3 years after Oumuamua was discovered, the same telescope in Hawaii discovered another object that was given the name 2020 SO. And a few months after the discovery of this object, they took a spectrum of it and realized that it's made of stainless steel. And then they realized that the trajectory is that of an upper stage of a lunar surveyor mission that NASA launched in 1966. So it was it had very thin walls, and that's why it was pushed by reflecting sunlight. So here's an example of a dark comet for you, which behaved just like Oumuamua. And the point is that it's technological. It's not a comet. It's it's something else. And it's just like these experts were trained on studying zebras and then they go to the zoo and see an elephant. They would argue the elephant is a zebra without stripes, but it's a completely different animal. And I felt during that experience, just like the kid in Hans Christian Andersen's tale that says the emperor has no clothes. I didn't see any evidence for a cometary tale, but the adults in the room were claiming that, yes, the emperor has clothes, but they're invisible.
Stay with us. We'll be right back.
This is an Afraid of Nothing paranormal podcast alert.
$10 merch. $10 merch.
That's right, podcast fans. If you go to our website, afraidofnothingpodcast.com, and click on the store tab, you too can find now $10 merch on the website. So not only can you get the great stuff like the hoodies and the t-shirts and the blankets and the glasses, you can also get stickers and bumper stickers and, well, a whole lot more. You need to see it yourself. But just remember this.
$10 merch
is now available at the Afraid of Nothing podcast store. Check it out. And remember, never be afraid to look good.
So, Oumuamua, am I correct in saying that was more of probably debris? And do you think that the Three-Eye Atlas is more of a complete type of, if it is an interstellar, object, that's going on the course? Is it like not debris, but actually a full kind of ship or whatever you might call it?
Well, yeah. So the anomalies of the two objects were quite different. In the case of Oumuamua, it was the very extreme shape that it had, most likely flat, and the non-gravitational acceleration that it showed that was pushing it away from the sun. In the case of Three-Eye Atlas, by the way, there were some hints of non-gravitational acceleration, but so far it's not statistically very significant. So we have an upper limit. They keep revising it down and down at the Jet Propulsion Lab as they track the motion of Three-Eye Atlas. And that means that it's a very massive object because we see it evaporating in difference from Oumuamua, and we know that it lost a significant amount of mass, but we don't notice any rocket effect, meaning that it's very massive. And in addition, in the case of Three-Eye Atlas, it also came in the plane of the planets around the sun, which indicates that, if it is technological, it had a purpose. That's why it's coming close to a variety of planets like Mars, Venus, and eventually Jupiter. So that's why I think if it is technological, it needs to be functional, because it also arrives at Jupiter just at the distance where Jupiter's gravity dominates over the sun's gravity. It's called the Hill radius, and it arrives at it to 4 significant digits, which is quite remarkable. Very high precision, exactly at the radius on the date that it arrives, that Jupiter dominates over the sun's gravity. This Hill radius is not a constant because Jupiter's orbit around the sun has some eccentricity, but I calculated the distance on the date that Three-Eye Atlas will come closest to Jupiter, and it turns out that it's identical to the Hill radius at that time. So that's a very surprising coincidence. Chance of that is 1 in 26,000, a very small probability given the diameter of the orbit of Jupiter around the sun. So there are these strange anomalies, and if it is technological, it must be functional. But it's also possible that, we just happen to be lucky that we got a big package in the plane of the planets around the sun, so we can use all the space assets to observe it. Maybe we're lucky, but it's a very small probability to be lucky that way, and it will take a while before we have another random object that arrives so big and also so bright and also in the plane of the planets around the sun.
Are we just noticing these now in the past couple of years just because we didn't pay attention before, or do you think we'll see more in the future?
We didn't have survey telescope with the capability of seeing such objects or monitoring them, and only over the past decade we developed them because the Congress tasked NASA to find near-Earth objects. So, for example, Pan-STARRS that discovered Oumuamua, or now we have the Rubin Observatory, and also Atlas, were all with the purpose of finding near-Earth objects. Because Congress tasked NASA to find more than 90% of the objects bigger than a football field that may come close to Earth. And so that's the motivation. And because we constructed these survey telescopes, we started finding objects that come close to Earth but are moving too fast to be bound to the sun. Just by chance, Oumuamua was flagged just because it came close to Earth. It had nothing to do with its speed. But then the astronomers measured the speed and realized, oh, wait, this one it moves too fast to be bound by gravity to the sun. So that was the first. And so we found them as a byproduct, but the Rubin Observatory in the coming decade may find one every few months because it's using a 3.2 gigapixel camera and will survey the southern sky every 4 days. What we need is a copy of the Rubin Observatory to monitor the northern sky. Right now, we have only one hemisphere that is being monitored.
Wow, that seems short-sighted, definitely. Can we talk about can you talk about the Galileo project and what you started a couple years ago and how it's grown and how the mission has evolved?
Right. So we are now getting to the most exciting phase where we will monitor in the coming year millions of objects in the sky. We do it at 3 locations, one in Massachusetts, another one in Pennsylvania, and a third one in Nevada. And we just constructed 3 units in Las Vegas that are separated by 10 kilometers from each other. One of the units is on the Sphere, which is the biggest entertainment center in the world. And that would allow us to monitor objects in the sky, measure their speed, their acceleration, their distance, and check if they are outside the performance envelope of human-made technologies. That's what we are after. And we were motivated because of the reports from the U.S. Intelligence agencies to the U.S. Congress about objects they cannot identify, which basically means that they're not doing their job. I mean, there is $1 trillion in the defense budget for 2026, and if the Pentagon sees objects that they cannot identify, that's a problem. And obviously, they would classify all this information because they don't want people to look over their shoulders and tell them you're not doing your job, despite the huge funding. So they keep it classified, and we just don't know. I mean, if these objects are produced by adversarial nations, it's a serious national security issue, and we better get to the bottom of it. However, if these are not human-made, then of course it's the biggest scientific discovery ever made. And in the latter case, that's what I'm interested in. And if government, for example, has information from 50 years ago, it cannot be kept secret because the technologies that humans employed 50 years ago are completely irrelevant nowadays. So my hope is that the government will release all the data that they don't regard as essential for national security. But even if they don't do it, the Galileo project is trying to check if there are any objects in the sky that are out of this Earth, out of this world. And I hope that in the coming years we'll know more about it, because we are doing it in a scientific way, just like any other astronomical observatory, except that we focus on objects close to Earth. We don't care about any human-made object because that is boring for me. I mean, obviously it's the focus of the intelligence agencies, but what we are doing is complementary to anything to do with national security.
Now, do you feel that this is more like it could be more of a probe, or do you think there could be any intelligent life on it, or it was just almost like an AI guided? I guess you can't know, but if you were going to surmise.
You mean the objects near Earth or in general?
The 3i Atlas, do you think?
Oh, 3i Atlas. Well, I prefer not to imagine, because our imagination is limited by what the script writers in Hollywood or science fiction writers thought about before. And nature could be far more imaginative, and the way I approach it is basically to look for things that deviate from what we expect. These are anomalous objects that show anomalies, things that we haven't expected. I should say that the current search methods are limited to velocities that are similar to the velocity of planets, the velocity of asteroids, comets. That's the kind of things that astronomers are looking for. If there is an object moving, much faster, we would probably miss it, because the speed of the typical objects in the solar system is up to about 1 part in 10,000 of the speed of light, and there is a lot of room for technological objects moving much faster than that. And if they do, we would miss them, because they would be smeared into a line in all the images that we take, very faint lines, and astronomers would just dismiss those lines. So there could be objects passing through that are much faster, and there could also be a lot of objects that are smaller than 3I Atlas. They estimate for its size is the width of Manhattan Island. It's quite large, and the biggest rocket that we produced is Starship, and that's less than 100 meters. So most of the objects, the spacecraft that we launched, are not visible to us within the Earth-Sun separation distance. They don't reflect enough sunlight. So there could be a lot of small objects of the type that we are launching that we haven't yet noticed, because they are not close enough. They don't reflect enough sunlight for our telescopes to notice them.
Now, the timeline, you covered it, started in, I guess, June or July, and then there were some certain things that were noticed in October, etc. When 3I Atlas went behind the sun and then was gone for not visible for NASA or our side of the hemisphere, and then it came out the other side, what was most surprising of it before and after, before it passed around the sun?
So, well, first, one of the anomalies was that it was hidden behind the sun when it came closest to the sun. We couldn't see it, and perhaps for a reason. We don't know what it did over there, but there were some observatories that looked at it from the side. These are observatories that orbit the sun separately from Earth, and they noticed that it gets extremely bright by a factor of 5 to 10 when it came close to the sun, and also bluer than the sun, which is paradoxical, because the surface of 3I Atlas at the distance that it was should have been much cooler than the sun. It should have been of order 250 degrees Kelvin above absolute zero, a factor of 20 smaller than that of the surface of the sun. So it should have been red. But one possibility, of course, is that there might be some molecules around it that produce the emission in the blue band, or that's a natural explanation, or a technological explanation would be that it has an engine that was used at closest approach to the sun, and the engine is very hot. It's a hot spot that was appearing as blue, and that is the best point for it to do a maneuver, actually, closest to the sun, to take advantage of the gravitational assist from the sun. So we just don't know what happened to it close to the sun, but now after perihelion, a lot of images from amateur astronomers indicated at least 7 jets that were noticed, and they went out to a distance of millions of kilometers, which is quite remarkable. And now we can see clearly with the image from the Hubble telescope on November 30th and other images that it has definitely an anti-tail pointing towards the sun, but also a tail pointing away from the sun. But the most prominent feature is the anti-tail. It's much brighter in the Hubble image. So we have to explain that. And I wrote 2 scientific papers trying to explain the anti-tail. We should be able to find the physics that describes it, because this was never seen for comets. I mean, sometimes some optical illusion from a vantage point. If we were to look at a comet from an angle that crosses the plane, the motion of the comets, we might have the illusion that it has an anti-tail in the direction of the sun, but it's always true that the tail is being pushed away from the sun because of the solar radiation, the solar wind. And in this case, it's clear that this was persistent all through the entire path of 3 Atlas from the beginning until now. So it needs to be explained. And as we get more data when it comes closest to Earth, that will happen on December 19th, we might get a better understanding of the nature of the object, because we can measure the speed of the jets, for example, and figure out whether they are a result of the sublimation of pockets of ice as a result of the illumination by the sun, or they might be some thrusters, technological thrusters that are used. And we can tell the difference based on the speed of the gas, because it's only hundreds of meters per second in the case of natural evaporation of pockets of ice, and it could be a few kilometers per second for chemical rockets, and a few tenths of kilometers per second for ion thrusters that are used in our spacecraft. So we will see if it looks like all the features belong to a natural object, then it appears to be a very rare and unusual object.
When it came around the sun afterwards, did it get bigger? Did the size get bigger of this thing at some point, or was that just the gases coming off of it that had that illusion?
No, it's getting closer to us, and therefore we can see lower. We can see farther out from it the glow, the halo, the coma that is around it, that includes gas. We don't fully understand the anti-tail. That could be due to a swarm of objects. I wrote a paper about it. If 3 Atlas is being pushed away from the sun by some non-gravitational acceleration, and these objects are not, then you will end up with these objects being closer, lagging behind 3 Atlas, and 3 Atlas leading them. And I calculated that it's just the right separation for the non-gravitational acceleration that was measured. So maybe that's the explanation. But so we don't know exactly what is around it, whether it's a swarm of small objects or whether it's gas only. But what we are seeing is indeed that the glow is bigger by about a factor of 10 right now than we measured it to be back when it was much farther away, a factor of 2 farther from Earth. And it was also a factor of 2 farther from the sun back then. So the brightness, it changes inverse. Even if it was like the same object, the brightness changes inversely with the distance to the 4th power, because the amount of sunlight intercepted by the object is proportional to 1 over distance squared, and then you have another factor of 1 over distance for the flux that is detected on Earth. And so part of the brightening has to do with it coming closer to us, and that's why we see a bigger halo around it. But it could also be that it released much more gas, and that's why it's bigger right now when it came closest to the sun.
Is the color of the anti-tail the same as the tail, or are they different, or does the color change as it goes on its journey?
The color did change. There were reports that it's green back. It started with red early on in July. Then it turned into green in August, and then there was a claim that it was blue when it came closest to the sun, and now it's sort of greenish blue again in November. So yes, the color does change, and that could be partly because of the gases around it and the excitation of those atoms and molecules by sunlight.
So what's the pulse of the room, in the scientific community as we get closer to the 19th? Are they nervous? Are they on eggshells? Are they excited? What's this?
I mean, the astronomers very much from the beginning, we're arguing it's a comet that just came from a natural object that came from another environment. And then, of course, initially they said that it's water rich, it must be water rich. And then it turns out that only 4% of the gas around it by mass is water. So my point is that the argument that it's a comet, a natural object, was there to start with, irrespective of the details, and the details changed, and that didn't matter. And also, the fact that it's in the trajectory is in the plane of the planets, which is a very small probability event, is also ignored. So in the NASA press conference, all the anomalies were not even discussed. The only one that was briefly mentioned was the nickel without the iron, but the argument is, okay, well, there are lots of unusual things about comets, so this is one of them. But they don't explain the anti-tail. They don't explain the unusual composition of nickel without iron. They don't explain why it's in the plane of the planets. They don't explain the very high mass of the object so far. Of course, if it turns out that the object is much smaller than we thought, then there will not be any tension. If it's less than a kilometer in size, it would be completely reasonable. But currently, it's much bigger than that. And so what NASA should have said is, there are a number of facts about this object that make it quite unusual, and we need to clarify the origin of these properties by collecting more data. Let's stay curious. Why should we say that it must be something that is familiar to us when it's not?
So do you think, cause it's obviously an object with kind of an intentional path, right? It's not just being pushed around by the universe. Any idea where it's going? Is it gonna, I'm guessing the answer is no, but the path of this thing, do you think it'll like pass us and then come back on the backside and we'll see it again in a billion years?
We don't have any evidence as of now for a significant course correction. And given the path that it's on, it would pass by Jupiter on March 16th, and after that, head out of the region within Jupiter's orbit. And as far as we can tell, it will just leave the solar system. Now, the fundamental mission could be for it to deposit some devices either next to Jupiter, because it's passing exactly at the right distance to deposit something at the Lagrange points, for example. We put the Webb telescope at the second Lagrange point around Earth because that's where you don't need much fuel. There is no course correction that is required. And so if you wanted to deposit a satellite near Jupiter, that would be a good place to arrive at. And maybe the mission is related to depositing some devices. Now, if that's the case, then we should be able to detect those new objects once they are there, because we have the Juno mission near Jupiter. There is also the JUICE mission on its way to Jupiter. Interestingly, JUICE, which was a mission launched by the European Space Agency, ESA, it came close to 3I Atlas within about 50 million kilometers in the first week of November. So it obtained the data on it, and then JUICE it's on its way to Jupiter as well, but it will get there only in July 2031, whereas 3 Atlas will get to Jupiter on March 16th, 2026. Just to show you how much faster is 3 Atlas moving relative to human-made spacecraft.
Yeah, I have to wonder. I must imagine, has the number of students that have tried to enroll in your course, has there been a lot more interest in your department the past couple of years since all this stuff has been happening?
There is a huge amount of interest all over the world. I now have about 5 million readers a month for my essays on medium.com. I just appeared on Joe Rogan, and within a few weeks it got 7 million views. And my student told me, an undergraduate student told me a few days ago that he went to the dining hall of the undergrads and he heard a group of students talking about me. Also, the student went to Yale and learned that there is a group of students at Yale that meet once a week and to discuss my essays on Medium.com every week. There is a huge amount of attention, so much so that our dishwasher broke down, and I had to order a new one. So when I called the service person, I didn't even tell him my name. I just said hello and that I'm interested in buying something. And he said, "Is this Avi Loeb?" Because he just recognized me from my voice on the phone. And he said, "I'm following you everywhere." I just went to Best Buy to get an iPad just an hour ago, and a young salesperson there said that he watched me on Joe Rogan. And so there is a lot of attention, which is very good. Newt Gingrich, the former Speaker of the House, invited me for a podcast a week ago, and he said, "Thank you so much for doing what you did over the past few months, because now the awareness to space exploration is so much greater." And the biggest reward I have is that there are lots of parents telling me that their kids now want to become scientists. And to me, that is, irrespective of whether 3i Atlas happens to be a rock, that is a great contribution that its passage made here on Earth. It really is very important that young people will follow and become scientists, because there are so many mysteries that my generation failed to solve.
Yeah, I mean, people probably starting to look up at the skies and paying attention, as well as seeing you in the stores. That's fantastic. I mean, do you see? I've heard before, like you've put out an idea that it should be international protocols to watch and manage this activity. Would you just close and talk a little bit about your thoughts on that and where you think that's going?
Yeah, so I wrote a white paper and sent it to the United Nations, trying to encourage them to establish an organization. I mean, it has to be international, because we are all in the same boat as humans here on Earth, and we better cooperate in bringing together scientists, policymakers, and communication media people, because this subject obviously will have an impact on society in a very unusual way. But I'm not naive to expect any significant motion in this direction until we have clear evidence for alien technology. I just hope that the fact that I speak about it will convince scientists to get as much data as possible to prove me wrong. Because once we have the data and it does show anomalies that cannot be explained, then of course there will be no way out of it. The worst we can do is just assume we know the answer and not even look. And that has been the practice in the past. We just don't know how much traffic of technological objects there is. And people say, "Oh, the probability that just now these objects will appear." Well, it's not about these objects appearing. It's about us being aware of the traffic. So there could be a lot of cars passing through the highway, but if your windows are closed and you never step outside, you would never notice how many cars are passing. So, and by the way, if just imagine that you see a cloud of dust, and there are experts that study horses all their life, and they would say, "Oh, there must be a horse running out there far away," and you would say, "No, it could be also a car." And that is the situation we are facing with those interstellar comets, because just the existence of gas and dust around them is only informing us of the skin of the objects, doesn't say much about what's inside. They could have collected ice and dust in the environments that they were born in. And if they collected those ices as they moved through the interstellar medium over billions of years, these ices would naturally vaporize or sublimate when the object gets close to the sun, but doesn't mean that it's a comet. You have to study whether the object maneuvers, whether it has artificial lights, whether there is some heat associated with an engine. There are all kinds of technological signatures, but if you assume that you know the answer, you're not seeking that data, and that's the worst situation that I hope we will never ever again be in, the way we were with Oumuamua. There the astronomy community said it's a comet to start with, then no cometary tail, no evaporation. They said it's an asteroid, it's a rock. But then we detected non-gravitational acceleration. So now they say it's a dark comet.
Yeah, it's what I really like, the 4 times you've spoken, you've really not been shy about being proven wrong. You just want to ask the intellectual question and not be afraid to ask the intellectual question. And you've been a great kind of mentor to young students to be fearless, to not feel bad if I ask this question, am I going to lose my chance at tenure or whatever, that I need to ask.
That's the only way by which we can learn something we don't expect, if we are willing to take risks and be wrong. And so I think it's really important to be open-minded, because otherwise you get into a mode where you guess the answer and you just don't check if you are wrong. And that is really not the way by which science can make discoveries.
Are you writing another book? Are you going to write a book about 3I Atlas, you think? Or
I might, but I actually just finished a book about the expedition to the Pacific Ocean that I led, and there will be a Netflix documentary about it coming out in 2026. So my next book is already written. It will come out with MIT Press in 2026 about the expedition to the Pacific Ocean in search for the materials of the first interstellar meteor that we went after to check its nature.
Are you happy with how it came out with a Netflix documentary? Have you seen it? Or
no, I haven't seen it.
But
I hope it's good. I have an indication that it's good because someone else saw it and approached me, a girl from another country. She said that she's in a club where Netflix asks for advice, and she couldn't help herself but contact me and say how amazing the work I'm doing is. So
that's awesome.
To me, it indicated that it must be a good documentary, because otherwise she wouldn't be so excited. She stopped in the middle of it and looked for my contact information and let me know that it's remarkable. So
well, finally something to look forward to, with all the bad things going on in the world. So we look forward to that. So Avi, thank you so much for your time today, and thank you for being accessible. You are a rare person, and I'll tell you, you probably don't even remember me the couple times that we've talked before because it was just audio, but you've always respond. If you're busy, you say, catch me after this point, and you do respond back. And you're a gentleman and definitely a scholar and a good influence on our young, evolving astrophysicists. So thank you for your time today, and keep doing what you're doing.
Thanks for having me. I don't see myself any different from the public. I just have the privilege of following on the curiosity of the public and trying to help resolve some of the fundamental questions we have about the universe. So thanks for having me.
You've been listening to the Afraid of Nothing podcast. Please subscribe and like us on Facebook. Until next time, stay scared.
Hey, you're still here? Great. Then why not listen to another episode? Visit afraidofnothingpodcast.com to peruse all the shows. That's afraidofnothingpodcast.com. And while you're there, click the coffee cup icon to buy me a coffee and leave a review. I'll give you a shout out in an upcoming episode, and the world will know how swell you are.